Hello viewers, I welcome you to today's episode of Learning with EXACT Study Points. Okay, in today's video, we shall be looking at a particular topic in differential equation, okay, called exactness of an equation. Obviously, this topic is one of the types of first order differential equation where we have homogeneous, we have variable separable, we have exactness of an equation, and so on. So in today's video, we shall be looking at this particular topic called exactness of an equation, and we shall be solving some questions relating to this topic. So let us look at it. The differential equation, the differential of the form P x comma y dy and Q x comma y dx equals 0 is said to be an exact. If and only if dp over dy is equals dq over dx. So we have the differential equation of the form P open bracket x comma y dy and Q open bracket x comma y dx equals 0 is said to be an exact if the partial derivative of P is equal to the partial derivative of y. Okay, we have 3 questions before us and we are expected to solve these questions using the application of exactness of an equation. Okay, it's very simple. We have the solution. Okay, so we have dz equals 2xy plus 6x dx plus s squared plus 2y cubed equals dy equals 0. Okay, this is the logic. The first thing we need to do is to make this first part to be equals to q, and we recall that this part is equals to p, or another way around, we can say this part is equals p and this part is equals q. So we have let p equals 2xy plus 6x. At the same time, q equals x squared plus 2y to the power of 3. Now, the next step or the next process is to differentiate p with respect to y. At the same time, we differentiate q to the respect to x. So we have dp over dy is equals, if I should differentiate this with respect to y, I'm going to have, of course, this becomes 0 because it does not have any variable of y. At the same time, this becomes what? This becomes 2x, because 1 to the power of 1 minus 1 becomes 0, means our power of 0 becomes 1. So we have 1 times 2x gives us 2x. So if I differentiate 2xy with respect to y, I'm going to have 2x. At the same time, if I differentiate this dq dx, I'm going to have, of course, this does not have x, so this becomes 0. So this have 2x. Obviously, we can see that dp over dy is equals to dq over dx. That is to tell us that this equation is exact. Therefore, this equation is exact because it satisfies the condition that dp over dy must be equal to the q over the x. You can see what I have here. If and only if dp over dy is equal to dq over the x, because dp over dy is 2x and dq over the x is 2x, meaning the equation is exact. Now what we need to do is let p equals dz over dx, which is equals to this, we have open bracket 2xy plus 6x dx. So we have z is equals to 2xy plus 6x dx. So we need to integrate this with respect to x. So we have integral of 2xy plus 6x dx. Alright, so if you integrate 2xy with respect to x, I'm going to have 2x squared y over what? Over 2. Plus, if I integrate this with respect to x at the same time, I'm going to have 6x squared over 2 plus f of y. Now, this goes with this, and this goes with this. We have 3. So we have x squared y plus 3x squared plus f of y. Now we need to do what we've done here to the other part as well, which is q. So we have let q equals dz over dy, which is equals to what? Which is equals to x squared plus 2y raised to power 3 dy. So we have z equals x squared plus 2y raised to power 3 dy. You can see that if I integrate this, as well, we must have one actually variable that must look the same. We must have one particular variable that must look the same. Okay, so we have integral of x squared plus 2y raised to power 3 dy. If I should integrate this with respect to y, I'm going to have x squared y plus, if I integrate this, I'm going to have 2y with the power of 4 over 4 plus f of x. Now, this here 2, this here 1. So we have x squared y plus y to the power of 4 over 2 plus f of x. Now, what we need to do is to compare the two answers. We need to compare the two answers. This is for q. At the same time, this is for p. Now we can see that they have one thing in common, which is x squared y. Here at the same time we have x squared 1. So we are going to pick just one of them. So we have, because we need to combine the two expressions together. So we need to compare this and compare this. The one with distinct or the one with the same variable, we take one out of it. So here is the common expression that we have in both q and p. So this becomes x squared y, we pick one of them, plus 3x squared plus y to the power of 4 over 2 equals 0. And that is the answer. That is how to solve an exactness of an equation. So let us look at second question that says dz equals x squared plus y squared plus x dx plus xy dx may dy equals 0. Now let us make this to be p, at the same time this to be q. So let p equals x squared plus y squared plus x, q equals xy at the same time. So if I differentiate p with respect to y, that will give me, if I differentiate this with respect to y, this becomes 0, this becomes 0 as well, this becomes 2y. At the same time, if I differentiate q with respect to x, I'm going to have q with respect to x, I'm going to have y. Now we can see dp over dy is equals to 2 and dq over dx is equals y. That is to tell us that this equation is not exact because it must follow this condition that dp over dy must always be equal to dq over dx. In a nutshell, we have dp over dy is not equal to dq over dx. That is to tell us that this equation is not exact. Okay, now what are we going to do for us to make this equation to be an exact equation? So what we need to do is to introduce what we call integrating factor. Okay, so we have, first of all, we need to introduce this formula dp over dy minus dq over dx over q. Okay, let us introduce this formula. Now, our dp over dy, which is what? Which is 2y. 2y minus our dq over dx, which is y. We have y all over q. And what happens to be our q? Our q is xy. So in here we have what? In here we have 2y minus y. That will give us y over x minus y. At the same time, this can go with this and we have 1 over x. So p if is equals to 1 over x. Of course, if means integrating factor. Now what we need to do now is to introduce what we call if. Integrating factor is equals to exponential raised to the power of integral of p dx. Now, which we have exponential to the power of integral of our p is what? 1 over x. 1 over x dx. And of course, this is equals to exponential. If I should integrate, if I should integrate 1 over x with respect to x, I'm going to have what we call ln x. Ln x. And recall that exponential to the power of exponential raised to the power of ln x is equals to x. Now we need to use this x to multiply our real question. And the real question is what? The real question is x squared plus y squared plus x dx plus xy dy equals 0. So if I should use x that I get here to multiply through, I'm going to have what? I'm going to have x raised to power 3 plus xy squared plus x squared dx plus x raised to power 2y dy equals 0. Okay, now what we need to do now is to follow our normal process, that let p equals what? Equals x raised to power 3 plus xy squared plus x squared. At the same time, q is equals x squared y. Now we need to differentiate p with respect to y, differentiate q with respect to x. So dp over dy is equals, if I should differentiate this with respect to y, I'm going to have 2, okay, xy, yes. At the same time, if I should differentiate q with respect to x, I'm going to have 2 xy. You can see that the equation is not exact. dp over dy is equals to dq over dx. So as you can see that the equation is exact because dp over dy is equals to dq over dx. Now the next step we need to carry out is to integrate the equation with respect to x at the same time with respect to y. Now we call this as p, isn't it? Okay, p equals, let's say p equals dz over dx, which is equals to what? Which is equals to x raised to power 3 plus x raised to xy squared plus x squared dx. That is to tell us that z is equals to x raised to power 3 plus xy squared plus x squared dx. Now we need to integrate this expression with respect to x. So we have integral of x raised to power 3 plus xy squared plus x squared dx. Now if I integrate this, if I integrate 3 cube with respect to x, I'm going to have x raised to power 4 over 4. I believe you still remember our laws of integration and differentiation. Okay, plus if I integrate xy squared with respect to x at the same time, I'm going to have x squared y squared over 2. Plus if I integrate this with respect to x at the same time, I'm going to have x raised to power 3 over 3 plus what? Plus f of y, because we're introducing with x, isn't it? Now this is for the first expression. The second expression, we have q is equals dz over dy, which is equals to what? Which is equals to x squared y. Now z is equals what? x squared y dy. We need to integrate this with respect to y. Integral of x squared y dy. So if I should integrate x squared y with respect to y, I'm going to have x squared y squared over 2 plus f of x. Now, you know, in our first example, I said after you might have tested the equation and the equation is exact, that is the differentiation of p, the p over dy is equal to the q over the x. At the same time, whenever you integrate that particular question, you must have just one answer or just one variable that is common to the integration of x and integration of y. Now, looking at this expression, we have a particular variable that is common to both dy and the x. Now, in here we have x squared y squared over 2, and here we have x squared y squared over 2. The next thing to do is to compare the two answers. Okay, so first of all, we must pick the one that are the same. Of course, this is the same thing as this, so we pick one of them, which is what? X squared y squared over 2 plus, now we go with x raised to power 3 over 3 plus x raised to power 4 over 4 plus power 4 equals what? Equals 0. So let us quickly solve the last question, then we call it a day. So we have dz equals 2xy minus sine x dx plus x squared minus cos y dy equals 0. Okay, so we follow the normal process where this is equals p, this is equals q, then we differentiate this with respect to y, we differentiate q with respect to x. Okay, so let p equals 2xy minus sine x. Okay, at the same time we have let q equals x squared minus cos y. So let us differentiate p. dp over dy equals, if I should differentiate p with respect to y, I'm going to have, of course we know that sine x does not have y, so automatically minus sine x automatically becomes 0. So here we have, if I differentiate 2xy with respect to y, I'm going to have 2x. So dq over dx is equals, this does not have x at the same time, so automatically it becomes 0. So if I should differentiate x squared with respect to x, I'm going to have 2x. So that is to tell us that dp over dy is equals dq over dx, meaning the equation is exact. Now, what we need to do now is to integrate the first part with respect to x, at the same time the second part with respect to y. So we have let p equals dz over dx, which is equals to 2xy minus sine x dx. Now z equals 2xy minus sine x dx. So we are going to integrate 2xy minus sine x dx. So if I should integrate 2xy with respect to x, I'm going to have 2x squared y over 2 minus, okay, so if I should integrate minus sine x with respect to x, I'm going to have plus cos s plus f of y. Now this goes with this. I have x squared y plus cos x plus f of y. Now we need to do the same thing to this other part as well, where we have let q equals x squared minus cos y dy. Now we have integral of s squared minus cos y dy. So we need to integrate this with respect to y. So if I should integrate with respect to y, I'm going to have x squared y. Okay, if I should integrate minus cos y with respect to y, I'm going to have minus sine y plus f of x. Now, you know, I said something in previous two examples that whenever our equation is exact and when we integrate, one variable must have the same value in both with respect to x and of course with respect to y. As you can see that x squared y is common to both sides, x squared y is here, and at the same time x squared y is common at the top. So we are going to pick just one of it. So we have x squared y, okay, plus cos x minus sine y equals 0. And that is how to solve questions relating to exactness of an equation. Thank you for watching. God bless you and stay safe.